All right, for lesson 2, we're going to talk about significant figures and reading lab equipment. They both go hand in hand. So significant figures you might not have heard before, but these are going to be very important to communicate the uncertainty of measurements in the lab. They're essentially very important for researchers and chemists, but we're going to kind of use them in terms of how we read equipment. So significant figures are going to be all exact digits of a measurement plus one uncertain digit. So just as a reminder, in terms of rounding off numbers, if a number immediately following the number to be rounded is less than 5, we're going to go ahead and round down. If it's more than 5, we're going to go ahead and round up, and so forth. That's just to be a common reminder. Now when we get to number of significant figures. Number 1 rule here is that all non-zero numbers are significant. So if we look here, 732 would be 3 sig figs, and so forth. There are no zeros here. Rule number 2 is any zeros between non-zero numbers are significant. So if it's sandwiched 0 around others that are not, those are going to be significant. So if you think of 301 centimeters, that would have 3, and the next one would have 7, and the next one would have 4. Where it gets tricky, though, is if you have a 0 at the end or the beginning of a number. That's what we need to really work on here. So if there's a decimal point, any zeros to the right of the last non-zero number are significant. Okay? So if you look at this first example here, 320, there's a decimal point there. So that would be 3 sig figs. But 320 without a decimal point at the end would just be 2. You might ask, why would you put a decimal point there? Well, that's going to convey where you were rounding in lab. Okay? All right, so if we go ahead and kind of look at this hint here, I think this is going to help make it more sense. If the decimal is absent, you're going to ignore zeros on the Atlantic side of the non-zero numbers. Okay, so no zeros, or no decimal point, you're going to ignore to the right. If the decimal is present, ignore zeros that are on the left. Okay, you're going to count all the other numbers. So for example, if it's absent, ignore the ones on the right. So we would ignore these last 2 zeros to make it 4. We would ignore these last 3 to make it 5, and ignore these last 3 to make it 2. If it's present, we're going to ignore these 3 on the left to make it 5. Ignore these, all of these, to make it 2. And then in this last example, ignore the first 2 to make it 3. So in terms of practice here, we're going to determine the number of sig figs in the following numbers. So since the first one, there is no decimal point at the end or anything, we ignore all of them to the right of the last non-zero number, meaning we have 2 sig figs. For B here, we have 306,800. Again, no decimal point, so we can ignore the last 2, meaning we have 4 sig figs. This one here, the decimal is present, so we're going to ignore all on the left of the non-zero number. So we ignore these first 4, making it 3. And the last, or this D, I should say, example here, decimal points present, we ignore the first one, making it 3 as well. Decimal points present, ignore the first 2, count the rest, 1, 2, 3, 4, 5. And the last one has a sandwiched 0, so that does matter. So there are 4 here. Okay? All right, and then, like I said, sig figs comes from how you round. So it communicates the uncertainty of a measure of measurements in lab. Okay, so you basically should always estimate one place. So when we talk about reading lab equipment and getting these numbers ourselves, we need to make sure that we are reading one extra place. Okay, so when we look at these here, we try to look at them and try to read, we want to figure out how they're calibrated. Okay, so if they're calibrated to the tens place, read one place past. If they're calibrated to the ones place, read one place past. If it's calibrated to the tens, read one place past to the hundredths, and so forth. So this first one here, I want to look and try to figure out how it's calibrated. So we have 400. So it's calibrated 20, 40, 60, 80, 500. Okay. So it's calibrated to the tens place. Okay. With the 20s, 40s, and so forth. So that means we need to read to the ones place. So I know that this is 420, this is 440. That means that I read to the meniscus, which is on the bottom. If I read across, that feels like it might be slightly underneath that line where the meniscus is in the middle here. So I'm going to say that this first one to me looks like 439. Maybe to you it looks like 440 even, maybe it looks like 438 to you. But just know that you are reading to the ones place. So if you were to write down 440 here, because you think it looks pretty even, you're going to want to put that decimal point there to show me that you know that you need to read to the ones place. You just think it's right on the line. If we look at the second example here, this one is calibrated to the ones. We have 21, 2, 3, 4, 5, and so forth. Okay, so we need to read to the tenths place. So I'm going to look up here at the meniscus in the middle here, So it's 7. I would say it looks like it's 7 on the dot, so I'm going to write 7.0. That communicates to me with that 0 that you know you need to read one place past. Next one here, this one is calibrated to the tens as well. So we've got to 10, 20, 30, 40, and 50. So we need to read to the ones place again. This one also feels like it's slightly below this line to me in the middle where the meniscus is. So I'm going to read that one as 249. Okay. All right. So when you give these next two a try, see if you get numbers that agree or are close to me. I'd say this one's 37.0, and I'd say this one's about 19.9. Okay. All right. So go ahead and see what you get there, and make sure that you're kind of making mental note and recording to the place that you really need to be recording to.